What if I told you that the mind-bending notion of our universe being nothing more than a high-tech computer game on some cosmic supercomputer has been mathematically dismantled? It's a thrilling concept that's fueled countless sci-fi stories, but groundbreaking research from UBC Okanagan's team has delivered a definitive verdict. Not only is it improbable, but it's downright impossible. Stick around, because we're about to dive into why this matters, and trust me, it gets even more intriguing as we go. Dr. Mir Faisal, an adjunct professor at UBC Okanagan's Irving K. Barber Faculty of Science, teamed up with international experts including Drs. Lawrence M. Krauss, Arzhid Shabir, and Francesco Marino. Together, they've uncovered that the very essence of reality functions in a manner that's utterly beyond any computer's capabilities. Their discoveries, detailed in the Journal of Holography Applications in Physics, accessible at https://jopi.du.ac.ir/article_for88.html, surpass mere speculation about whether we're trapped in a matrix-like virtual world. Instead, they establish a deeper truth: the cosmos is rooted in a form of insight that algorithms simply can't touch. People have proposed that our reality might be a simulation, explains Dr. Faisal. If that's feasible, then the simulated world could spawn life forms that create their own nested simulations, making it statistically improbable that we're the base a universe rather than a layered copy. This concept was once beyond scientific scrutiny, but our latest work shows it's now open to rigorous mathematical examination. At the heart of this revelation lies a captivating aspect of existence itself. Physics has evolved dramatically since Newton's era of solid objects interacting in empty space. Einstein's relativity overhauled that view, followed by quantum mechanics, which revolutionized our grasp of the tiny world. Now, the frontier theory of quantum gravity hints that space and time aren't even basic building blocks, they spring from something more profound: unadulterated information. This information dwells in what's known as a Platonic domain, a purely mathematical bedrock that's more authentic than the tangible reality we navigate. From this abstract layer, the dimensions of space and time materialize. But here's where it gets controversial: the researchers prove that even this informational core can't be fully captured through computing power alone. Leveraging robust mathematical principles, such as Gödel's incompleteness theorem, they argue that a thorough and coherent depiction of everything demands a non-algorithmic understanding. To make this clearer for newcomers, picture a computer as a meticulous chef following a recipe step by step, no deviations. Yet, certain fundamental truths can only be apprehended via non-algorithmic insight, comprehension that defies any chain of logical instructions. These are Gödelian truths, genuine but unprovable by machines. For a simple illustration, consider this paradox: this statement is true, yet unprovable. If you could verify it, it would contradict itself and shatter logic. If it's unverifiable, it's valid, but that leaves the entire system incomplete. Pure computation just can't handle it. It's like trying to solve a puzzle with missing pieces. As Dr. Faisal puts it, we've shown that it's impossible to encapsulate every facet of physical reality within a computational framework of quantum gravity. Thus, no all-encompassing, consistent theory of everything can stem from algorithms alone. It necessitates non-algorithmic understanding, which is even more basic than the computational rules of quantum gravity and, by extension, more fundamental than space and time. You might wonder, if the Platonic realm's rules mimic a computer's operations, could it itself be simulated? Absolutely not, the team insists. Their analysis digs deeper, drawing on theorems about incompleteness and indefinability. A fully accurate and whole description of reality can't be attained via computation, Dr. Faisal clarifies. It hinges on non-algorithmic understanding, which is inherently beyond algorithmic reach and thus unsimulable. Therefore, our universe isn't, and never could be, a simulation. Co-author Dr. Lawrence M. Krauss highlights the sweeping ramifications: the core principles of physics transcend space and time, as they spawn them. For ages, scientists dreamed of a grand theory that computes everything from these principles. But we've proven that's unattainable. A total, harmonious account of reality calls for something richer, a non-algorithmic form of comprehension. The group's findings are unequivocal and represent a landmark in science, according to Dr. Faisal. Every simulation operates algorithmically, bound by coded instructions. Yet, since the deepest layer of reality relies on non-algorithmic insight, the universe is fundamentally unsimulable. The simulation theory, once dismissed as unprovable and confined to philosophical debates or fiction, has now entered the realm of math and physics with this irrefutable proof. For more details, check out the paper, Mir Faisal et al., Consequences of Undecidability in Physics on the Theory of Everything, Journal of Holography Applications in Physics, 2025. DOI 10.22128 JARP.2025.1024.1118 https://dx.doi.org/102228/jopi.2025.1024.1118. Also on R14, DOI 10.48550 tarxiv.2507.22950 https://dx.doi.org/10.for8550/r14.250.22950. Journal reference R14 https://physics.org/journals/r14. Citation: Mathematical proof debunks the idea that the universe is a computer simulation. 2025, October 30th. Retrieved 30 October 2025 from https://physics.org/news/2025-10-proof-debunks-idea-universe.html. This document is subject to copyright. Apart from any fair dealing for the purpose of private study or research, no part may be reproduced without the written permission. The content is provided for information purposes only. And this is the part most people miss. Could there be a counter-argument that quantum mechanics itself is just another layer of illusion? Some might say this proof closes the door on simulations, but others could argue it opens up debates about what understanding really means in an infinite multiverse. What do you think? Does this settle the simulation hypothesis once and for all, or do you see flaws in assuming non-algorithmic elements? Share your thoughts in the comments, agree, disagree, or propose an alternative view. Let's keep the conversation going.